Today's video is about atomic structure. While you're watching this video, I need you to keep the following two questions in mind. The first, what are the three main subatomic particles? The second, where in the atom are those particles located? There are three main subatomic particles. The first is the proton. The proton has a positive charge and an atomic mass unit of 1. We generally represent protons with a little plus sign representing the positive charge. You can remember protons, plus, and positive all start with the letter P. Then we have the neutrons. The neutrons, like the protons, are located in the nucleus of the atom. Unlike the protons, they have a neutral charge. They have an atomic mass unit of 1, and we represent them with a small 0. Finally, we have the electrons. The electrons are not located in the nucleus. They are located outside in the electron cloud. They have a negative charge, represented by a minus sign, and they have a very small atomic mass. So small, we generally don't consider it when we're looking at the atomic mass of an element. Here's a brace map. As you know, brace maps are used to show parts of a whole. If we take the atom itself, we can break it down into two sections, the nucleus and the electron cloud. The electron cloud, the outside of the atom, is where the electrons are found. The nucleus, which is in the inside of the atom, is where the protons and neutrons are found. When you look at the box for a periodic table for any one of the elements, you can get information to tell you how many protons, neutrons, and electrons any given atom might have. Right now we're going to look at information for carbon. The top number, 12.01, is the atomic mass. You'll notice that the atomic mass is always the larger of the two numbers because it's adding up the mass of the protons and the neutrons. You'll also notice that it's a decimal. That's because it represents an average of all the different isotopes of the element carbon. When you're doing atomic math, you'll need to make sure that you use your rounding rules to round up or round down before you do any calculations. Next we have the chemical symbol. Chemical symbol for carbon is one that makes sense. It's a C. Not all elements have symbols that make sense. For example, Pb is lead, W is tungsten, and Au is gold. A lot of times it comes from old-fashioned names from the elements, or it might come from a Latin name or a different language like Wolfram for tungsten, comes from German. Then we have the element's name, and finally we have the smaller of the two numbers, which is the atomic number. The atomic number is always the number of protons. Sometimes it's the number of the electrons, and it can be used in combination with the atomic mass to determine the number of neutrons. Here's how we do a little atomic math. The atomic number is equal to the number of protons always. Always, 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 no exception. If you have a different number of protons, you have a totally different element. So for example, carbon has 6, neon has 10, gold has 79, hydrogen has 1. None of those are going to change. If you end up with a different number of protons, you now have a new element. The atomic number may equal the number of electrons. If the atom is balanced and it has an equal number of positive and negative charges, then your number of protons and electrons will be the same. However, in real life, this doesn't happen that often. What happens a lot of the time is that some of the electrons leave the electron cloud and go visit a friend. When this happens, you have a different number of electrons than protons, and you now have a particle called an ion. Finally, the atomic mass minus the atomic number equals the number of neutrons. Basically, you're taking the mass of the protons and neutrons together, subtracting just the protons alone, and that is going to give you the number of neutrons. If you have an unusual number of neutrons, then that means you have a substance called an isotope. And now we're going to use a simulation to build a couple atoms. First one we're going to do is hydrogen. Number 1 on the periodic table, number 1 in your hearts. We're going to start with the proton. Notice when I drag proton up, it's going to give us the name hydrogen. If I add a second proton, it's now going to give us helium. Like I said, if you change the protons, you change your element. Notice I've added a box for the symbols, box for the mass number, and a box that shows us the net charge. Right now it is a positive ion because we have one proton and no electrons to balance it. That means we've got one more positive charge. It gives it a net charge of +1. So let's give it an electron. And now it's a neutral atom. The positive and negative charge balance out. Notice here that this element is stable. Most hydrogen is going to travel around like this. One little proton with one little electron. Sometimes it'll pick up another electron. It's still stable, but now it's a negative ion. This is one of the reasons hydrogen is so useful and bonds with so many different things. It's very flexible in terms of its bonding. I can also add a neutron. I've now doubled its atomic mass. It's still a stable atom. This would be an example of a hydrogen isotope. Now we're going to build carbon. Carbon, if you remember, has an atomic number of 6. So I'm going to give it 6 protons. 1, 2, 3, 4, 5, 6. And again, note as I added each proton, the name changed, and it also went across the top of the periodic table, which are numbered in order of atomic number. This right now is very unstable. Let's add some neutrons to balance it off. We're going to give it 6 neutrons, because an atomic mass of 12.001 rounds down to 12. 12 minus 6 is 6, and this gives us what's called carbon-12, the most common carbon isotope. And you notice once I added that last one, it's now stable. Now we need to give it some electrons. Notice the first 2 electrons I give it go into this first energy level. Once the first energy level has 2 electrons in it, that first energy level is considered full. There's no more room, so I have to move to the next energy level. The next energy level can take up to 8 electrons, but for carbon we only need 4 to make it a neutral atom. Again, we look at its symbol, carbon, atomic mass of 12, atomic number of 6. As this atom is right here, it's got no charge. Its mass number is 12, 6 protons, 6 neutrons. Its net charge is 0 because your number of protons is balanced by your number of electrons.